In-office verification of rigid gas permeable lenses is one of the most important steps in successfully fitting RGPs. It enables the contact lens practitioner to ensure that lens specifications ordered have been fulfilled. This program features RGP verification procedures. These techniques are easily acquired through practice and can give you optimum control over the lens quality, lens fit, and patient comfort. RGP verification is important prior to dispensing, periodically during follow-up care, and after symptoms related to lens defects are reported. The variety of lens materials available today makes it difficult to determine by case history alone which type a patient has been wearing. Use of a specific gravity kit is the first step in verifying lens material. The lens is placed in a series of solutions, having a progressively higher specific gravity. Identification is possible when the lens sinks in a particular solution. Contact lens power is verified with a lensometer in much the same manner as measuring spectacles. The back vertex power, measured in diopters, can be determined by centering the concave side of the contact against the lens stop. Practitioners and labs generally refer to back vertex power, since phoropters, corrective curve trial lenses, and spectacle lenses are referenced in this way. When measuring, notice the reticle can be brought into focus evenly. This indicates the lens is a single power or a spherical lens. The power is the same in all meridians. In our example, the spherical contact lens is measured to be -1.5 diopters. With a toric contact lens, the reticle lines 90 degrees apart must be brought into focus separately. This indicates the lens has two different powers. This toric contact lens is measured to be +3/4 diopter in one meridian and -4 diopters 90 degrees away. With a prism ballasted bifocal lens, be extra careful about centering the lens on the stop. The prism power can be determined by the amount of decentration of the target in relation to the center of the reticle. Each ring corresponds to one prism diopter. In our example, the amount is 1 prism diopter. The base curve radius of a rigid gas permeable contact lens can be best determined by using a radioscope. This measurement is the most crucial parameter to verify since it relates directly to the lens to cornea fitting relationship. RGP lenses should be soaked 24 hours prior to verification, as the material may flatten upon hydration. Soaking also enhances lens surface wettability. Measuring a spherical lens, notice the reticle or spoke pattern can be brought into focus evenly. This indicates a single base curve or a spherical lens. If a degraded spoke pattern is observed while measuring the base curve radius, it may be attributed to a dry lens well. This is easily resolved by adding water to the radioscope lens mount. A dirty lens. Proper cleaning will significantly improve the image. A warped lens also results in a degraded image. The reticle lines, 90 degrees apart, must be brought into focus separately. This indicates the warped lens has two different curves on the surface. Patients who suddenly complain of decreased wearing time, poor vision, or take a spherocylindrical overrefraction may be experiencing either a warped lens or lens flexure. A lens that exhibits flexure will not show a degraded radioscope image. Toric lens base curves are verified much like a warped lens. However, a toric lens is intentionally designed with two different curves. It generally has a much greater dioptric difference between the curves than a warped lens. Verification of the lens design